Let's do another exchange economy. So here I've assumed that player B has a linear utility function. So now the indifference curves of player B will be straight lines, and this will have some interesting consequences compared to the previous videos. The rest here is self-explanatory by now. We have 6 units of each good, and we have a certain allocation. To solve the model, step 1 is to equate the marginal rates of substitution. This gives us equation 1, and we can then solve equation 1 for x2 to a. It says x2b here, I'm sorry, that's a typo. We solve equation 1 for x2a. This gives us equation 2. And this defines points that are Pareto efficient and are therefore part of the contract curve. But there will also be other points that are part of the contract curve, as we shall see. To find all the points, consider the set given here, where x1a is 6 and x2a is greater than 3. If you go back to the previous slide and calculate the marginal rates of substitution for these values, you will find that player A has a greater marginal rate of substitution. So he wants to buy good 1 and player B wants to sell good 1. So this would make it possible for them to trade. But player A already has all the units of good 1 in this case. So it's impossible for them to trade. There's nothing more that player A can buy. He already has everything of good 1. And therefore, they cannot trade anywhere else in such a way that it's a Pareto improvement. And hence, the points in that set must be Pareto efficient. And therefore, the complete contract curve is given by equation CC here. Here is the Edgeworth box. I have drawn the contract curve, which is the red line, and I have drawn the indifference curves that go through some of the points on the contract curve. I've also drawn the initial allocation, which is C1, and C2 and C3, which are just points on the contract curve. Now, the point here is that if you look at the part of the contract curve that is interior, that is not on the border of the box, you will see that at those points, the indifference curves are exactly tangent. That's the case, for example, at point C2. But if you look at the parts of the contract curve that are on the border, you will see that the indifference curves are not tangent. They're close to being tangent, but not exactly. And that's why they can still trade, or rather, I should say, they still want to trade. They want to trade down and to the right if they are at point C3, but they can't do that because that would put them somewhere outside of the Edgeworth box. And therefore, point C3 is part of the contract curve. The next step in solving the model is to take the marginal rate of substitution for player A and equate it with the marginal rate of transformation, which is the price ratio. And since we assume, as usual, that the price of good 1 is equal to 1, we can easily solve this for P2, which gives us equation 4. Next, we substitute equation 4 into the monetary constraint of player A, giving us equation 5. We solve equation 5 for x2a, giving us equation 6. And then we can equate equation 6 with the contract curve, CC, which gives us equation 7. And this expression only contains one variable, x1a. So we can solve this for x1a, which gives us a value of 9/2, or 4.5. Then, having found x1a, we just go back to the previous equations that we used to find the other variables, x2a, x1b, x2b, and from equation 4 we get the price of good 2, which is 2. So we have the whole solution. We can also derive the monetary constraints. Since we have the prices, we can put them in the monetary constraint for player A, and we get equation 8. And this is the line along which they will trade. And as in the previous cases, the solution is where this line intersects the contract curve. Here is the Edgeworth box again. I have drawn the contract curve, the line along which they trade, the budget line, along with the initial allocation and the optimal allocation, C star, and the core, which is the blue line. As you can see, they trade, in fact, along the indifference curve of player B. And this is because at C star, well, we have defined C star in such a way that the budget line is tangent to both of the indifference curves at that point. And so what they do is trade along exactly the indifference curve of player B, meaning that player B does not benefit from these trades. He exchanges the goods in such a way that his utility is exactly the same. But player A benefits at each point. For every trade they make, player A benefits. Now, the solution we found is interior, meaning that it's not on the border. But this was because we had an initial allocation which produced that result. It could be that we have an initial allocation in the upper right part of the Edgeworth box. In this case, they will trade to a part of the contract curve which is on the border. For example, if the initial allocation is 5-5, then they would like to trade to a point outside of the Edgeworth box. But since they cannot do that, they will stop once they reach the edge, and the optimal allocation will be on the border. Here, I've given you the budget line along which they will trade when the initial allocation is 5-5. It crosses the contract curve at the point 6 and 4.5, which is the solution. And this is what it will look like graphically. Now C1 is the point 5-5. That's where they start. And what they would like to do is to trade to the point C2, because at that point, their marginal rates of substitution is the same. So they can no longer trade in such a way that they both benefit. So they will trade along the budget line in the direction of C2. But when they get to the edge of the box, they cannot trade anymore, because trading more would violate the physical constraints. So they stop at the point C star, which is the solution.